Hi everyone, this is our second video for the solutions to the 2025 Maths Extension 1 HSC paper. In this video we're going to look at questions 11 and 12. 11a, find the inverse function of the function f of x is equal to 1 take away 1 over x minus 2. Alright, we're going to start by switching the x and the y. So we're going to have x is equal to 1 minus 1 over y minus 2. So that, I'm just going to take that over that side and this over this side. So 1 over y minus 2 is equal to 1 minus x. And then switching them, 1 over 1 minus x is equal to y minus 2. And so y is equal to 2 plus 1 over 1 minus x. 11b. Solve sine 2 theta, take away sine theta is equal to 0. For 0 is less than or equal to theta is less than or equal to pi. That's important there. Okay, so we've got sine 2 theta, take away sine theta is equal to 0. We know that sine 2 theta is 2 sine theta cos theta. And then factorising that sine theta out, it's 2 cos theta take 1 is equal to 0. So either sine theta is equal to 0 or cos theta is equal to a half. All right, now we only want to be in these first two quadrants because of this. And our sine curve looks like this. So it's equal to 0 at 0 and pi. And cos, just in this first quadrant here, if cos theta is equal to a half, then theta is equal to 60 degrees, that's pi on 3. So our solutions are theta is equal to 0, pi on 3, and pi. 11c, find the integral of sine 3x cos x dx. Now that's one of those identities. I'm just going to grab my formula sheet, which is somewhere. Here it is. Look that up because I can't remember those off the top of my head. It is sine cos, so we have got sine A cos B is equal to a half of sine A plus B plus sine A minus B. Okay, so this will equal the integral of a half sine A plus B is 4x, A minus B is 2x. And now we can integrate. Let's bring that half out the front. We have got, I've got a chain rule here, so outside function is sine, that's going to become negative cos 4x divided by the derivative of the inside function, which is 4. And then it'll be minus sine, cos 2x, it's the same process, divided by 2, plus c. And just tidying that up, actually we've pretty much got the answer at this point anyway. It's equal to negative 1/8 cos 4x take away 1/4 cos 2x plus c. 11d, sketch the graph of y is equal to 1/3 inverse cos of 2x. So our normal inverse cos graph looks like this. And it goes between negative 1 and 1 and 0 and pi. Now this third here is going to squish it vertically, and this one here is also going to squish it horizontally. So we're going to end up with, same picture, but it's going to go between negative a half and a half, and up to here it'll be pi on 3. (11e), for what value of m is the vector 1m parallel to the vector 2, 6? So we need this to be a scalar multiple of this vector. And obviously we have multiplied by 2 across the top, so we need to multiply by 2 across the bottom, and so m has to equal 3. 11f, The roots of 2x cubed plus 6x squared plus x minus 1 equals 0 alpha, beta, and gamma. What is the value of 1 on alpha, beta, plus 1 on alpha, gamma, plus 1 on beta, gamma? So you're making a common denominator of alpha, beta, gamma. Missing from here is gamma, missing from here is beta, and missing from here is alpha. So we need the sum of the roots over the product of the roots. The sum of the roots is equal to minus b on a. So from here, that's negative 6 on 2, which is negative 3. And the product of the roots, c, is negative d on a. D is a negative 1, so that's 1 over, and a is 2. And so this is going to be equal to the sum of the roots is negative 3 divided by a half, which is equal to negative 6. 11g, evaluate the integral between pi on 6 and pi on 3 of cos squared 3x dx. So we need that identity, cos squared nx is equal to a half, and then brackets 1 plus cos 2nx, and n is equal to 3 in this case. So it's going to be a half outside of 1 plus cos 6x dx, bringing the half out the front, integrating x plus, we have a reverse chain rule here, outside function is cos, that becomes sine 6x, divided by the derivative of the inside function, which is 6, in between pi on 6 and pi on 3 equals a half. Substituting in pi on 3 plus sine 2 pi over 6, that's 0. Take away pi on 6 plus sine pi on 6, that is also 0. Equals a half. Pi on 3, take pi on 6, is equal to half times pi on 6, which is pi on 12. 12a. The radius r centimetres and angle theta radians of a sector vary in such a way that its area remains constant at 10 centimetres squared. The angle theta is increasing at a constant rate, so d theta dt, of 2 radians per second. Find the rate at which the radius is changing. So we want dr dt when the radius is 4 centimetres. Okay, so we're going to have related rates here. We want dr dt. We have d theta dt. So I'm going to adjust that. I want to get rid of the d theta and I want to put the r in. Okay, does it make sense? See, if you cancel those d thetas out, we have this. All right, we know what that is. We need to know this. So we're going to need an equation for r in terms of theta. And we're going to get that from the area of sector. Area of a sector is a half r squared theta, and we know that's always equal to 10. Making theta the subject, we have got 20r to the negative 2. d theta dr is equal to negative 40r to negative 3. We actually don't want d theta dr, we want dr d theta, so let's invert both sides. It's equal to negative r cubed on 40. All right, from here, dr dt is equal to d theta dt, which is 2, times negative r cubed on 40, which is equal to negative r cubed on 20. And at r is equal to 4, dr dt is equal to negative 64 on 20, which is negative 3.2 centimetres per second. 12b, consider the region bounded by the hyperbola y equals 1 over x, the y-axis and the lines y equals 1 and y equals a for a is greater than 1. Find the volume of a solid revolution formed when the region is rotated about the y-axis. All right, I'm going to draw this just quickly so I can see what's going on. We're going around the y-axis. We have got between 1 and some value a. There. Okay, so our volume is going to be pi. it's around the y-axis, so we want x squared, and it's going to go between 1 and a. So x is equal to 1 on y, x squared is equal to 1 on y squared, or y to the negative 2. So it's equal to pi, integral between 1 and a of y to the negative 2 dy is equal to pi, y to the negative 1 between 1 and a equals pi. I'm going to tidy that up. What is that? That's negative 1 on y between 1 and a is equal to pi. I've got negative 1 on a plus 1 is the answer. Just going to tidy it up. Units cubed. 12c, prove by mathematical induction that 1 times 1 factorial plus 2 times 2 factorial plus ... plus n times n factorial is equal to n plus 1 factorial, take away 1. For all integers n greater than or equal to 1. So we'll start with n is equal to 1. Our left-hand side is equal to 1 times 1 factorial, which is 1. Our right-hand side is equal to 1 plus 1 factorial, take away 1, which is 2, take away 1, which is 1. So it's true for n is equal to 1. We're going to assume it's true for n equals k. I'm going to put it in summation. It's not a very good sum sign, but never mind. R is equal to 1 up to k of r times r factorial would equal k plus 1 factorial, take away 1. And we are required to prove this. Equal to k plus 2 factorial, take away 1. So, sum from r is equal to 1 to k plus 1 of r times r factorial must be equal to the sum from r equals 1 to k of r times r factorial plus k plus 1 multiplied by k plus 1 factorial. And using our assumption, this is equal to this. So k plus 1 factorial, take away 1, plus k plus 1 factorial. Let's factorize that k plus 1 factorial out of the first and the third terms. So that's 1 plus k plus 1, and I'm just going to put this minus 1 at the end. And tidying that up, we have got k plus 1 factorial multiplied by k plus 2, take away 1, which of course is k plus 2 factorial, take away 1 as required. Therefore, true for n is equal to k plus 1 by the principle of mathematical induction, true for all n. 12d, find the solution of dy dx is equal to the square root of 2 minus y, 2 plus y, given that y equals 1 when x is equal to 0. Alright, we're going to separate the variables here. We've got dy dx is equal to the square root of 4 take away y squared. I want this to go over that side, so I want 1 over the square root of 4 take y squared dy is going to be equal to the integral of 1 dx. Now this, of course, here is inverse sine. Let's just grab the formula. Inverse sine. That is there. So it's inverse sine of y over 2 is equal to x plus c. Now we happen to know that when y is equal to 1, x is equal to 0. So let's resolve the constant. We've got inverse sine of a half is equal to 0c. Therefore, c is equal to pi on 6. So we've got inverse sine of y on 2 is equal to x plus pi on 6. We want to make y the subject, so y on 2 will equal sine of x plus pi on 6, and taking the 2 over, y is equal to 2 lots of sine x plus pi on 6. 12e, part 1, express root 3 sine x, take away cos x, in the form 2 sine x minus alpha. Well, we know that alpha will equal inverse tan of this coefficient divided by this. We don't need to worry about this negative, it's accounted for there, so that's going to be a half, 1 on root 3, not a half. And inverse tan of 1 on root 3 is pi on 6. And so root 3 sine x take cos x will equal 2 sine x take pi on 6. Okay, so that's that done. Part 2. Hence or otherwise solve this, which is the same as root 3 sine x take cos x equals 1. So using what we just did in part 1, we have got 2 sine x take pi on 6 is equal to 1, so sine x take pi on 6 is equal to a half. And I want to solve this between 0 and 2 pi. So x take pi on 6. Inverse sine of a half is pi on 6. And I want in here and in here. So the other one is 5 pi on 6. And then taking that pi on 6 over, I get 2 pi on 6 and 6 pi on 6, which is pi on 3 and pi. Okay, so that's it for questions 11 and 12. Significantly easier than the multiple choice. In our final video, we're going to look at questions 13 and 14.